record. There we go. It's recording now. Um, so if you guys don't want you guys to be recorded or your faces, so you can switch your cameras off. But it's recording now. Okay, I'm about to share the screen. Okay, hopefully you guys can see my screen. And then I'm gonna start it from the beginning. Okay. There we go. So can you guys see the slideshow? Okay, yeah, perfect. Thank you. Okay, so we're gonna introduce R today. We're gonna work with R in our studio. There we go. So we'll just learn some basics about R, and we'll do some examples along the way. If you guys are very passionate about this and you see an example on a slide, you can absolutely go ahead and try it right then and there if you have two devices or something, but it's absolutely not necessary to do so. Okay. I will give you time to run a couple important things that I feel like you should run before doing anything. But yeah, other than that, if you see an example and you absolutely will feel like very passionate about it and you want to run it, go ahead. Feel free to do that. Okay. So what is R? I mean, I should ask that before going to the next slide, but what is R? Does anyone know? Any ideas?
It's just another coding language, right?
Mm-hmm. Programming language, yeah. Okay, so it's a open source and it's free. That's the big part of it. And it's mostly used for statistical computations. Okay. One of the major strengths of R is CRAN, right? Comprehensive Archive Network. And there are free packages available that we can download through the CRAN. Okay. I will put later, I will post, or can I post them now? I don't know. I can't copy this link. Okay, I will post these links later in the chat so you guys can go and read more about R and RStudio. Okay, R is a language, but RStudio is the environment, the integrated development environment to run the R programming. And this person, I feel these RStudio cheat sheets are absolutely amazing. Oh, there we go. Thank you, Austin, for posting those. But definitely, these RStudio cheat sheets are amazing. Personally speaking, as a student, they are good to have in hand. Okay. All right. So here is what the RStudio should look like. You can absolutely change this according to your comfort level. For example, I like it in dark mode, so I use R in dark mode. You can change multiple themes. If you want to know, I can show you later. But generally speaking, this is what your RStudio should look like. Those of you have RStudio open or have installed it, does it look like this? You don't have to have a code running or something, but it should have these 4 pieces at least. Sage dark mode, yeah, but cool. Yeah, I work with dark mode too, so cool. Thanks for your responses. That's pretty cool. Okay, all right. So these are the 4 pieces that you should see in your RStudio. Okay. All right. Workflow with RStudio. We have .r files that we can use, and I can give you code to copy and you can test and play with them. The .r files, they work for small tests, right? And it's easy to run those rather than, so R has something called just these .r files that you run in the console. There are some notebooks or Markdown you can use. Has anyone used like Python notebooks or Jupyter notebooks before this? Yeah. If you have used like Jupyter notebooks, it would, for you guys, it would feel our notebooks are very similar to those. You can write your text and your code at the same, in the same environment, and it would code and it would run at the same time. So that's pretty cool. But I think most of the time we are just going to work with .r files. Okay, so if you start writing your code, you can run selected lines of your code. You can run the whole code. You can use modify those lines, and then you can use shortcuts to run the codes. You can do multiple things. Okay. You probably have to save the .r file in order to run the code sometimes, unless you run in the console environment. Okay. Flexibility in running the code. You can click the run button above the editor panel. You can select the lines to run the code. You can hit the shortcut. Okay, so let's find what's the shortcut to run our code. Hover over your mouse to the run button for those of you who have RStudio open and tell me what's the shortcut. Yeah, it's Control plus Enter. Yes, yes. So you can absolutely select those lines and click Control plus Enter, and that would be it. And that's for Windows. Anyone has a Mac and want to tell me what it is for Mac? No one has a Mac? Okay, that's cool. I have a Windows too, so that's pretty cool. Okay. All right. All right, so working directories. That is really important. Now, tell me something. Why do we wanna work or set a working directory? Why is it so important to set a working directory? Anyone?
Isn't that where all of your files are saved?
Yeah, that's basically all. When you save our files generically, I don't know where it would save, right? It depends on your computer to computer. But if you want to know what your current working directory is, you just do get WD, which stands for get working directory. And it will tell you the location where this file is currently saved, if you don't know. In general, you can set a working directory by using the command setwd. I think that's on the slide as well. Yes. So if you use the function setwd, it's you can set your working directory. You can copy and paste your link there. I find it easier to set it manually using the second option in the RStudio rather than copying the link because it just messes up sometimes. But the cool part is when you use these commands, a session to set working directory, and you choose your directory where you want to save your file, it actually generates the setwd command. And for future use, you can use that. So that's pretty cool to see. It actually sets this command, this the setwd. Okay, any questions so far? Everyone okay? Everyone cool? Yeah, no questions? Yeah. Thanks for the thumbs up, Sindhu. Okay, exercise. Let's see. Let's create a new .r file. And those of you who have RStudio open, Amrita, the run button is on the top, and I can show you that in a minute. So let's run this demo code. Okay. I'm gonna pause my recording here. All right, so this is my dark mode RStudio. What I'm gonna do is I'm gonna create a new script. Okay. And Amrita, I think you asked where's the run button? Run button is right here. Okay. All right. So what you can do is, let's see, what was our command? So X and R, this is our assign operator. So I can say X goes 1, right? And my next command was, let's see. So when that Y goes X plus 1. So Y is X plus 1. Okay. So let's do this together. I hope you guys are doing it with me. Okay. And then we just have to print Y. Okay. Now, in order to run this, you'll probably have to save it, but I am just gonna run this in the console. So I'm gonna say, paste it here, and I'm gonna run this. So do you see that? Did everyone get 2 for their answer? Yeah. Is there any question? I hope you guys can see it. Let's see. So I'm gonna do this once again. In my console, why does it print every line before that? Why does it do it or why does it not? So X is 1. If I say, okay, let's see. This is what is called something called assignment operator with the arrow and the hyphen. So if I'm assigning something to X, and if I say X right here, and it would give me X. Now I'm using the console down there. Okay. All right. And then Y goes X plus 1. And it would just assign it. It wouldn't do anything. If I say Y, it would do Y. If I say print Y, it will again give me Y. Sorry, I use the capital Y, but I should use. All right. It will again give me the value of Y. Does that make sense? Any questions so far?
Yeah, so when I try to run the code, it says that object Y is not found, object X is not found, and all that stuff.
Did you save it, or are you running in the console?
I'm running it in the console, and it still says that it's not found.
Okay.
I can share my screen if you want.
That's okay. I'm gonna do something real quick here, and I will send you that in the chat and try that.
Okay, cool. Thank
you. So you can see. Sorry. Print Y. So what I'm gonna do is I'm gonna send you this. Let's see if I can copy this. Yeah, I can copy it in the chat. Okay, try this.
Okay, yeah, that seemed to work. I just don't know what I did wrong on the when I did it myself.
Okay, so what I think what would have happened is you could have not used the right letters. Maybe you capitalized some letters or something. So it's case sensitive. Okay, so make sure you use the right case. Okay.
Okay, yeah, I got it working. I did so I didn't have the symbols in the right place. So
okay, yeah. And then if it's not you're working, you can also like select those lines and then click run.
Okay, sweet, thank you.
Okay, all right. Okay, so I am seeing a couple questions. Sorry, lost. That's fine. And then, okay, so Miguel, that's a good question, and we are gonna, in general, I would say yes, and we are gonna also talk about that in a minute. Okay. All right. So I am gonna. All right, we're recording back again. Current slide. Let's do this. Okay, so we did that. And then, okay, so if you did this as R script, go ahead and save it as mycode.r in a folder where you know and you will remember it, okay? So make sure you do that. And then you can also later change the working directories and set the working directory that you want, okay? And then if you just want to run this code in just one, in console in just one way, just run it like that. And do not worry about this for now. It's just this one symbol in the brackets. Don't worry about it for now. Okay. All right. There are some built-in mathematical functions that we can use in R, which is super cool. So you can find the value of sine, cosine, like trig functions. For example, sine 1, you can find it. And then you can find the value of logarithm. If you use log 10, that is basically just saying log with the base 10. And then you can find the value of log 1, and you can see the value of log 1 is 0. We know that. And if you use log without any base, that means you're using it with what base? So log 10, if you can see the example up top on the right here, that is log 10. If you use log, just log of 1, if I have to find just log of 1, what base is that? Anyone? There's a hint here, natural log. What is the base of natural? Yeah, E. E is the base of natural log, right? Which in math, when we write it, we say ln. So that is, if you want to find ln of 1, technically in R, it's just log of 1. Okay? And then you can also find the e to the power, so exponentials, and you can easily find the values of them. Okay, and then the assignment operator. We just talked about it. What is the function of assignment operator? It just assigns a value to that variable. I hope everyone knows the difference between the constant and a variable. Any questions there? Yes, you can technically use equal to as an assignment operator in R, but I would prefer, or in general, our users prefer to use this as an assignment operator rather than equal to. But you can absolutely use it. There's nothing wrong with it, but we'll talk about it in a minute too. Okay. All right. Let's see. Assignment operators. What is the difference between this and that? So let's see. There's an example. Mean of x equals to 125. What is that? It gives you error, right? X not found, because it didn't really assign it to x. It just found the mean. If you would have said x equals to mean of something, that might give you the value of x. But since we used x equals to inside the function, it said x not found. Does that make sense? It didn't really assign that value to x here. Is that clear? Maybe, maybe not. Clear? Aries, it does not work the other way. Okay. Okay, let's see. So it says x is declared within the scope of the function. It does not exist in the user workspace. Okay. But whereas now I'm assigning x as 1 to 5. And now if I find, okay, it gives me mean, but also it gives me value of x if I try to find it. Okay. All right. So that's why it's good practice to use x, because you'll be like, oh, where did my x go? I already have an x. Where did it go? Okay. And then you can read more about it in this link. Wait, I can probably copy that. Not right now, maybe later. Okay. Anyway, now variables. There is a slide on variables too. Okay. So as we know, variables can contain letters, numbers, underscores, and periods, but no spaces. Okay. They must start with a letter or a period followed by a letter. They cannot start with a number or an underscore. Variables beginning with a period are hidden variables. Any questions there? These are just rules specific to R. Okay. Like every language has their own rules for variables. This is just rules for R. Okay. All right. How do you find help? If you need help for any function or something, you go to the console and then you just say question mark and then function name. But if you want to find more about the assignment operator, for example, or any operator, what you do is question mark and put that operator in the double quotes. Okay, you can also put it in single quotes, but just put it in the quotes to find more about it. But do put a question mark in front. But for the function names, if I want to find, okay, how does the mean function work, or what's the syntax of mean function in R, just say question mark mean, you'll know the documentation. Okay, and then if you certainly can't do anything, where did it go? Sorry. Here, you can ask, sorry, you can ask your classmates via instructor, and Google is of course there. Okay. All right. So R has 6 basic data types. It has character, like just symbol A is a character, or not, I shouldn't say a symbol, letter A. There's double, there's integer, there's logical. Logical basically just takes true or false. There's complex, you can take complex numbers, and then there's raw. There's raw force. And then you can combine these elements in these data types to form data structures. Okay, and you can know more about data structures as we work through them. Make sense? I am not following the chat, so hopefully. Louise, okay, yes, you can absolutely do that. Mean of 1 to 5, yes, it will give you the same thing. It was just an example to show the difference between the two assignment operators, the equal to and the other assignment operator. Does that make sense? Okay, perfect. All right, so now we can talk about data structures. It has many different data structures like vector, list, matrix, data frames, and factors. If you are trying to have a list, I shouldn't say list. So for example, I say X equals to, or X, the assignment operator, and in the parentheses, I give some numbers or something. It's basically a vector. Everything should start with a vector. And then we can form matrices, we can form lists, we can form data frames. Data frames are also consists of rows and columns. Does that make sense? And you probably will use data frames a lot. Data frames are really useful to use in R specifically. Okay, R vectors. So let's take an example. Suppose we have a dinner with our family and write down everyone's age. So mathematically, we can have a vector which has everyone's ages stored in it. How would we do that in R? We would do a combine function. We will use a combine function and we will assign it to a vector, right? So again, V here is just a letter. You can use any, you can use a vector such as age. You can call it age and you would know a descriptive name that this vector has the ages of people. Then you will use this combine function C and with the round parentheses, and you will type the numbers you want separated by commas. And if you see V, it would have the vector. It would come up as a vector. Any questions? No. Okay. So what if you want a vector containing the numbers 1 through 100? Well, then we have the colon, our colon sign, and then it would just list the numbers from 1 to 100 if you run through it. Okay, so if you want a vector of all zeros and we want specific like 100 zeros in that vector, you can just have C 1 to 100. That would just give you 1 to 100. But if you multiply that vector by 0, that means it would multiply each of the elements in that vector by 0. Does that make sense? And then you can also do this. You can do numeric and then 100 and then vector. It would generate a vector of zeros of that length. Okay. All right. There are more examples of vectors here. Okay. Let's say you have the numbers from 1 to 10, but what you really want are the square of those numbers. Now, how do I do that? So I have a vector v, which is, again, numbers from 1 to 10, but I want it square. So I create another variable w, where I assign it to be v square. And how do I do that? V to the exponent square 2. So if I print w, what it did was basically went to the vector v, took each of its element and squared it and gave you the result. And we can see that here. Okay. All right. Vectorization. The vectorization now. Vectorization means that an operation such as squaring a number is applied to each element of the vector in turn, right? Like we saw in the previous slide. If I can go back right here. So we had a vector of 10 numbers, the first 10 numbers, right? When we did v square, what it did was it took each element. So 1 square is 1, 2 square is 4, 3 square is 9. So it took each element of that vector and squared it. Okay. So that's what vectorization is doing. You can do this with the sums. You can do this with the products, right? And you can do this in the loops. Okay. Right. So how to create matrices? There are multiple ways to create matrices. There's an example given here. So let's say we gather the high temperatures of 5 cities: Merced, San Francisco, LA, and Las Vegas, and Seattle, over the 5 days in August. So we store the data in a matrix. So they just gave it an, so first step is to create an empty matrix. So that's what they did. Using a matrix command, they created an empty matrix of zeros, right? And then n row is number of rows you want, and n columns is the number of columns you want. So since we have 5 cities and we want to record the highest temperatures in for first 5 days in August, so we are creating a 5 by 5 matrix. Okay. So we initially, when we started, we just said it should be all the values should be zeros in the matrix. Okay. So now, again, we are now note that here we are using the square brackets. So when here, because R knows the temps is a matrix, right? So whenever in a matrix you have to access some element in a matrix, you use the row and the column number, right? So just before I tell you about the syntax more, if you look below the generated matrix, so the 102, the first element, it's in the first row in the first column, right? So first row and first column, I have 102. So if I have to get to that, I would have to specify what row it is and what column it is. So what they're doing here is they're just taking the first column, they're filling it column wise, right? And they're saying, okay, the row is empty, but the first column should look like this. Okay, then second column should look like this. All the rows would fill automatically. So this is the values that should go in the first column, the next in the second column, and the third column, and the fourth and the fifth, so on. And then when you run that, and then when you call the temps, you will see a matrix generated like this. Does that make sense? Any questions on matrices? It will fill row wise where it happen? Yes, it will. It can fill row wise, just like that. Okay, all right. Okay. So matrices are intuitive and correspond to mathematical objects we learned about in, let's say, in just a specific class, Math 24, but you could have learned in different classes. We can give the names to rows and columns, right? So these matrices can have names. So for example, here we want our column names to be the names of those cities we took. So the command that goes is call names, COL names, and then you specify what is the name of that matrix, like which matrix do you want to name the columns of. And then again, you use assignment operator and then the combine option. And since here you are giving a character entries, so you put them in the quotes. Okay, if you just put Merced, it wouldn't recognize what Merced is. So we are telling it that this is the name, so we are putting it in the quotes, it's correct. And then again, if you run your matrix temps, you will see now the columns would have their names. So that's really helpful when you're doing some calculations. Okay. Similarly, if you want to name the rows, you would just use the command row names and you would follow the same steps. Okay. All right. Now we're going to talk about data frame. This is personally for me, I use this command a lot in R. When I'm doing R, I use this command a lot. So a data frame is the most common way of storing data in R and generally is the data structure most often used for data analysis. Okay. So if you use data.frame, you can convert a matrix to a data frame. You can just put the name of the matrix and would convert it into a data frame. Okay. Data frame have column names, which can be accessed or modified with the names function. Okay. So data frame will have column names. Okay. So, and you can, let's say you want just the names of the columns that your data has in a data frame. So you just use names and the name of your data frame, and it would give the name of the columns. That's sometimes really, really helpful. Okay, so how do you convert a matrix into a data frame? So you use the data.frame and you put your, what's it called? The name of the matrix. Now here, what we did was they changed the names of what it was to in double quotes. Let's see. I'm sorry. Yeah, they just put it in double quotes because sometimes when you do data frames, it could take the names of those. So it could consider that names as the first row of the data frame, but we don't want that. So that's why they said these things are actually the names of the columns and it's not actually a row in that data frame. Does that make sense? I hope it does. So in order for our data frame to not consider these names as a row in the data frame, so we just did this again so that it would know that these are the column names in the data frame and not a valid entry in the data frame. Okay. And then when you run a data frame, just call it and then it would show you that data frame. Okay. And what if you want to create a data frame directly? What you are about to do is just put these. Okay, I said Merced had these temperatures, San Francisco had these temperatures, LA has this, Vegas, Seattle. And then when you have to combine, you just combine them, data.frame, and you just combine all these vectors that you created. So you created 5 vectors, and when you combine these vectors, they'll give you these column vectors into a data frame. Okay. All right. So you can do a bunch of stuff with data frames. For example, you can find the mean. So how would you do that? So for example, I want to find the mean temperature of just Merced. So how do you call that column? So you say mean, the name of your data frame, the $sign, and then the name of the column. Okay, so $sign basically knows that you are specifying the name of the column or the variable to access that. Does that make sense? Any questions? And similarly, you can do with other columns too. All right. So that's about data frames. So you can add columns to data frames. Okay. How to add a column. So for example, they just added a date column. They said they created a date vector. And then they said tdat new. So they are creating another data frame. So you see, this is a new data frame, tdat underscore new. There's a new data frame. And this, okay, I'll tell you this something. So there's something called cbind, which is called column bind. So what it's going to do is it's going to combine the by columns using this date, the new vector you created, to this data frame. And then your new data frame looks like this, which has now another column. So it has 6 columns now. It has a date column. Okay. All right. So cbind is a very, very helpful function in R. You can do a lot with it. Okay. Note, if you try to add a vector of dates with a different number of entries than the number of rows in a different, it will fail. Absolutely. So we had 5 rows. Let's say you add, you have a vector with 6 entries, and then you try to combine it, then it would fail. Or in this case, the example they gave it was they had a vector with 4 entries, and they try to combine that to the data frame, it would fail because the number of rows in the columns didn't match. Those slides. Yeah, these slides are already posted. They should be visible to you on CAT courses. Okay. How about adding rows, right? You can also use rbind to add rows, but it can get sometimes like cumbersome and complicated to do that. So for now, let's just focus on cbind. Okay. All right. So you can also remove columns from a data frame. What you have to do is basically the data frame, the name of the data frame, and then the column you want to remove, you can just say minus that and leave the first thing empty so that it doesn't remove the, so it knows all the entries in that row, but that column. Okay. So we'll remove that. You just have to add the negative sign to it. Or you can use this operator, in operator. It's from a library called Tidyverse, and it's a little bit more complicated. But once you get to know Tidyverse, you wouldn't want to do the normal R functions ever again. So, but yeah, you can absolutely do that too if you want. Okay. All right. So handling special cases. So there are several special functions you can use to filter out special values like missing, infinite, or undefined data. So if you want to find, let's say you have a data frame, you want to find in this column how many are NAs, right? So that you can remove those rows, so you can find, oh, is there any NA? It will return the positions of the vector where our matrix or data frame where you have NAs in your data. Or you can use isNaN if you have NaN values or infinite values. So you can use is.infinite. Is.infinite will return all positions in a vector, matrix, or data frame that do not contain NA, NaN, or infinite. Okay, so there's different. You can do is infinite, and then there is something called is finite. Okay, so finite will return all the positions in a vector matrix that do not contain NA, NaN, or infinite. So if you just want to extract the data which is neither NAs, NaNs, or infinite data, so you can use is.finite, and it will return where in the data frame you have finite values. Okay, or in that vector you have finite values. And if you want to filter out something and you want to omit the NA values, for example, so you can use the NA.omit in combination with is.NA or something, and it would basically filter out your NA values or the missing values. Okay. All right. Let's see. Okay, repeating operators. So there's you probably in this class won't have to do much with the for loops. Like if a for loop is given, you won't really have to adjust it a lot or something, by maybe a little bit, but I think you should know what a for loop does or how does it work. So basic structure is for iterator in a set values, do something. Okay, for example, for I is our iterator that would move. In this range of values, I print I. Okay. All right. Well, let's do this. Okay, experimental simulations in R. We calculated probabilities in the lecture, probably you guys did that. And then now we can do the simulations, right? We can create a vector, earn, and then we can use a sample to generate the samples. And then you can use these kind of things to do simulations like sum and double equal to. Now, what does double equal to do? Can anyone tell me what does double equal to do? What's the function of doing double equal to?
That's like a condition, right?
It can compare, it can check the values. So if I say if whether if I double equal to 2 or not, right? So it's just checking, and it's giving us, yes, you're right, Boolean, it's giving me yes or no values, true or false. Okay. And then for example, the code you got from the worksheet, it It's called sampling from earns.r, and it's doing this. It has 8 balls, 4 red and 4 black, and you're drawing 4 balls without replacement, and then you plot the probabilities. Okay. All right. So there's a R function called sample, which you can use to sample these values or sample the balls in the earn. And then you can say replace true or false. So you know what to do with, you want to do it without replacement or with replacement. VEC is a vector you're sampling from. And then NT is the number of samples you would like. Okay, so this is a basic syntax. Sample from this vector, number of the samples you want, and replace equals to false if you were doing without replacement, and replace equals to true if you're doing with replacement. Okay, right. So we start with an earn filled with 4 red and 4 black balls, randomly mixed. I draw 4 balls from the earn, sampling without replacement. What is the probability that at least one is black? So I have this vector earn, and so notice here how they created this earn vector, right? They said replicate 4 red. So it will do 4 red, 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 red. So 4 times, and then it would do replicate black 4 times. So you have this data frame kind of thing called earns, right? And then you say, I want to draw 4 out of those. So now I have 8 values in this vector earn. 4 are red and 4 are black. So randomly, it's gonna sample out 4 of these values. So draw ball, sample from this earn vector. How many I want to sample? I want 4 balls, and I do not want any replacement. So I say replace equals to false. So when it draws balls, it gives me 1 red, 1 black, black again, and then red again in this order. Okay. So determine which balls drawn are black, right? So draw balls double equal to black. So the first one was red. If you go back a slide, the first one was red, so it gave me false because it's not black. Second was black, so it gave me true. The third was black, it gave me true. The fourth was red again, so it gave me false. So double equal to is basically checking. Okay, so we have now produced a vector of true and false, right? So R considers true as 1 and false as 0. And then we can sum these, right? If you save it in a vector, you can sum it. And then so sum, draw balls double equal to black. So how many black balls were drawn? 2. And similarly, if you do draw balls equals to red, it would again give you 1, 0, 0, 1. And then again, when you sum it, it can again give you 2. Okay? Any questions? Okay. Right. So here's the code, and you will have been provided with it. So for your worksheet, you will have to just edit it a little bit to work with it. So here's what the functions we were talking about just now. Okay. And then in the code, you will also see there's a plot code. So where you plot the empirical probability compared with the true probability. Okay. And then your main assignment, again, you will look that into the worksheet, is to change the code to draw 3 balls without replacement from a total of 10 balls, where 3 of them are red and 7 are black. You only need to change few lines in the code. So, and if you still have questions, like, of course, I'm there to help you. And then you have to show the output for at least 2 different numbers of total trials, n equals to 10 squared and n equals to 10 to the 4th. And then you have to write up your results in the worksheet too. Okay. And there goes my